Okay, we've got the data and we're told that it follows this relationship. So let's see if that's the case. Here y equals mx plus c. So the gradient m is just the value a when we read it off, and the intercept is just the value b when we read it off from the graph. We only need to plot w against p on the x and y axes, so it's nice and straightforward. No algebra needed here. So let's have a go at that then. Okay, I'm not going to do too big a graph here. That'll have to do. Let's have a look at it. Okay, good. So, P and W. P is a y-axis, W goes up to 112, so it's 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 20, 40, 60, 80, 100, 120, and this is the w-axis, the x-axis, and then the p-axis here goes up to 35, so it's 10, 20, 30, and 40. There we go. Let's mark off the points 14 and 5.1. 14 and 5.1 would be here. 42 and 13.3 about here. 60 and 19.1 would be about here, say. And then 84 and 26 about here. And then 112 and 35. Excuse me. So there's the best sketch I can do. So I'm going to try and do the digital pen. I'll try and come down with it. It's hard to see it sometimes. Let's use the pen and mark it off here. Okay, and then I'm going to come down with a digital line. I can't see it on the... got it. There it is, I think. Nope, back a bit. Where is it going to come then? Well, it looks to me like it's just a smidge above. Is that okay? No, it's a bit lower than that, isn't it? So I'm going to go down a bit more. What about that one? It's very near 0 at the bottom there. Yeah, it must be 0 because the effort to lift nothing is nothing. So yeah, that's why it's going through 0 there. So let's put it through 0. Okay, so that's that. And I'll draw it there then. Good, because power to weight, the power needed to lift a weight, well, there's no power needed to lift an empty object, so that's why it was going through 0. So we can put that through definitely. Okay, just read off the intercept then. I'll go along 100, and what value is this here? And that'll be nice and accurate then. So there's the 100 value, which is about here. So what height is that? What is it? 30, say 2. 31.5. I'm going to guess 31.5. So that height is 31.5, isn't it? The distance across the triangle underneath the line is 100. So 31.5, the gradient, which is A, is equal to 31.5 over 100, which I'm going to say is approximately 0.3. That should be okay from the accuracy that I can obtain. So A equals 0.3 then. A is the gradient, B is the intercept, so B would be 0. So the rule then, P equals AW, P equals 0.3 times W plus 0, and when W equals 50, P would equal 0.3 times 50 is 15, 0.3 times 50, 15, that's the power required to lift the load. Okay, so the solutions, let me just have a quick look for question 4, see how close I am to the answer. It's 0.307, which is not too bad for my inaccurate attempt at plotting a graph. And the intercept they've got is 0.603. So I'm quite way out here. They've actually made it above 0. But when you look at the context of the question, the effort P required to lift the load W, well, I would have put it through 0 anyway because of the context of the question. But they've actually just fitted it to blindly to the closest fit and got a value of that of 0.603, which is small anyway. Okay.